Hello and welcome back to the Ground Up Advanced Flight Tutorial. Thank you very much for joining me this video, and today we're going to be looking at autopilot systems. So if you want to know all about autopilot systems, or at least the basics of how to use autopilot systems, stay tuned because this is going to be the video for you. However, if you have not yet learned how to fly crosswinds and do not understand VORs, I highly recommend you go back and have a look at the lessons where I talk about understanding VORs and how to use them, and understanding about crosswind takeoffs, landings and flying in a crosswind, because we do have a crosswind today, quite a strong crosswind blowing from 180 across at about I think it's about 16 knots. Then we've got a 16 knot crosswind going from 180 across or thereabouts. So that's pretty strong. It's going to make for a very interesting takeoff. I can guarantee I'm probably going to mess that up. But you need to know about crosswind takeoffs. I'm not going to be explaining crosswind takeoffs at all. There is a 3-part video all about crosswind takeoffs, flying and landing. So you guys need to go watch that if you haven't seen it yet. Also, I'm not going to be explaining VORs in this particular video either. So if you don't know what a VOR is or how to use a VOR, I recommend that you go and do that as well. You need to go see that video where I talk about VOR and VOR navigation. We are at Echo Golf November X-Ray. We are set up on runway 09. As we always are. Like I said, we've got a crosswind literally blowing right the way across the runway. No headwind, no tailwind, or negligible tailwind and headwind. It's all completely negligible. So we're in a Malibu. We're in a Piper PA-46 Malibu. It's kind of different to the Piper Arrow 3 that we've been flying for a while, but don't worry, you don't need to know any of the extra bits. We're going to be focusing on that instrument there today. Our airspeed indicator, our vertical speed, our altimeter, our attitude indicator, our turn coordinator, and our horizontal situation indicator or compass card. What we don't need is this line over here, this yellow line there. That is just a needle, just like this one over here. We're going to be using this one, so I'm going to tune in 115.7. If you guys are unsure as to what that is the Trent VOR. We're going to be using that today. There you go, job done. 115.7, 2 has come up, the lights come up, that is active, we're ready to go, and it's just like we've always used before. Not anything different, everything is the same there. Over here I'm going to tune in, if I switch the right thing, on this one I am going to tune in 109.35, just in case we decide to return to the airport in this video. So I'm going to do that, and you're going to see that this is going to change somewhat. Don't worry about that, and I am going to also have that turn to 90. Don't worry about this yellow line. Like I said, we're just going to be looking at this as a compass card. That is actually built-in navigation with the compass card. So you can see there, that is my glide slope indicator, and that yellow line at the moment is working as a localizer. If I were to go ahead and press 115.7, like so, you're going to see that's going to switch off, but look, there we go, that's just done exactly as you would expect. So if we want to be on the 90-degree radial, it's over on that side for us somewhere. So we know that, so don't worry about that. We're not going to be looking at that. What we are going to be looking at is this system over here. Now I need you guys to find one that looks like this on your aircraft. It needs to have some of these buttons. If it doesn't have buttons, I recommend you go to an aircraft that has buttons, just because it's going to be easier to understand. It's not really easy. Like, for example, I'm not using the Piper Arrow 3 because it's got an autopilot control system down here, which is just an absolute pain. So that's why I'm not using the Piper Arrow 3. We need to have a look at this. So we've got, as you can see, this is a CIS 55X, I think. Is that what it said? Yeah, CIS 55X. We've got different buttons over here. We're not going to be looking at all of them. We're going to be looking at this one, HDG, heading hold. We're going to be looking at this one, NAV, navigation. We're going to be ignoring APR, that's approach. We're going to be ignoring REV, that's back course or reverse. We're going to be looking at this one, ALT, altitude, and we're going to be looking at this one, vertical speed. Now, we might not look too much at vertical speed, but we are certainly going to be looking at altitude, heading, and navigation. particularly how heading and navigation are very, very different, and they are used in a very different way. So that's something that's going to be very important, and how they link to the rest of the systems. We're not going to be talking about PID controllers, how the autopilot works with all the feedback loops and everything like that. We don't need to worry about that. If you do want to know about that, if you join up or sign up to my Patreon scheme with the $5 reward, you'll have access to the Flight Sim Tutorials channel. I'm more than happy to go into this with charts and diagrams for hours and hours on end, explaining these controllers and how they work. It's very complicated, but it's something that I can explain because I'm surprisingly qualified to explain these things. Who would have thunk it? Yes, thunk, real word. Right, just interested to see what that's there. Okay. Compass may be incorrect, that's fine. Okay, so what we're going to do is we're going to take off and then get on with this. So first things first, I don't have head tracking on at the moment. We'll get that down. So we've got one stage of flaps. I feel like maybe it might be a bad idea to have flaps in this wind, but maybe if I get myself in the air as quickly as I possibly can, that would probably help out. Right, we'll do that. I'm going to actually trim this aircraft down a bit because I always find that this aircraft wants to pull up far too easily. So I'm going to trim the elevators down before we take off into the wind, and let's see what we can do. This is going to be very, very bad. I do apologize in advance for a very poor takeoff. Here we go. Ooh, it's struggling, it's fighting me. It's fighting me. As you can see, very, very, very difficult takeoff here. Rotate. And you can see just how windy it is. Look at the direction this aircraft is pointing and I've got the nose low on purpose to just show you how difficult this is currently to fly this aircraft. But we are up. Bring those flaps in, bring that gear up. We are good to go. Alright, so the first one we're going to learn about once we're in the air, we've got a lot of turbulence as well, it's going to be very difficult to fly, is going to be altitude hold. So altitude hold is, as it says, it will keep you at a specific altitude. Not so much of a problem. So for example, we want to get to 2,000 feet. So if I were to go ahead and press this button, or switch it on first, there we go. We're going to ignore the glide slope one right now, so I'll switch that off. If I were to do altitude hold and bring that up to say 2,500 feet, so on here it says 250, as you can see, that's 250. That is going to bring us, let's just do that. That's going to bring us up to 2,500 feet. That's all it's going to do, and it's going to do it in the way it feels is the best way possible. So it's doing it very, very gently right now at about 100 foot a minute. That's no good to us. We want to climb up a lot faster. I mean, we've got other. If we look over here, there's a whole bunch of stuff over here. Don't worry about all of this. We're not going to worry. We're just going to do it very basic at the moment. None of this stuff. And you can see there it says it's ready, it's going. We don't want to worry about this. We are more concerned with flying our aircraft correctly. So there we go. I'm doing a fair amount of speed, but you can see just how much it's wobbling, just how much turbulence there is. Autopilot comes in very handy in a moment like this, in cases like this where you've got a lot going on, so you need to be watching, you need to be trying to let the computer do whatever it can so you can focus on other things. Now that's not to say in an aircraft like this you need to be using autopilot. At this point in time I really wouldn't be using autopilot, but there we go, I need to show you guys, so that's why I'm doing it. So now we're going to press this vertical speed button. Now I hope this works. It worked when I tested it. So we press the vertical speed button and you can see it says there VS2, 200 foot per minute. We're going to increase that to VS 10. Now by increasing that, look what happens to our climb speed. you can just see it's going to start going upwards. And that's the idea here. There you go. You can see it climbing a little bit more. Now obviously the fact that we've got really bad turbulence is not helping out at all. But you can see that the aircraft is now wanting to climb. There you go. It's now up to 500 foot a minute. And as long as the trim can allow for it to compensate, remember it does have a trim setting. As long as the trim of an aircraft can allow it to compensate, it will do the climb it needs to do. So you can see it's attempting, it's definitely attempting to do its climb. Obviously being buffeted around a huge amount. Oh, there it goes. That was me playing with the trim just a little bit, and it's realised that it can do its climb. So now it should get the climb going about 1,000 foot per minute. At least that's what it should be doing in theory. For some reason, sometimes it doesn't want to do it in Flight Sim World. I'm not exactly sure why, but that's what it should be doing. And if I press it over here, it might want to do it. The vertical speed button there, right? There we go. That's probably switched on VS mode. I think that's switched on VS mode. Ha. Or not. Come on. I know we're in VS mode. Well, that's a little bit embarrassing. Basically, that is supposed to allow us to go up or down. You can see that little arrow there, that tells us that we are climbing. And if we go back, if we switch off that, we can see 2,500 is the altitude we're trying to get up to. It just doesn't seem to be wanting to do it in the way we want it to do it. That's okay though. It's probably something to do with this particular aircraft, which is just fine by me. That's decision height. We're not going to worry about any of that stuff there. We really don't need to worry about that. It's just altitude, vertical speed. Yeah, it keeps resetting the vertical speed. That's what it is. It's constantly resetting that vertical speed, which is not what we want. Aha! There we go. Now it's doing it. You can see there the vertical speed is now climbing just as we reach our 2,500 foot per minute, or 2,000. Let's actually bring this up to 3,000. Bring that vertical speed, bring that altitude in, and that should, in theory, get us up to where we want to go. Now we are turning. Let's get this aircraft straightened up a little bit. There we go. Alright, it's doing a 500 foot per minute climb of its own accord. I am not doing this, and you'll see that once we get to 3,000 feet, it is going to level itself out. And that's the advantages of having altitude on the autopilot and the vertical speed that doesn't seem to be particularly interested in working. As a matter of fact, it has no interest whatsoever in working. It's even telling me right here it doesn't want to work. Yeah, literally doesn't want to work. Whatever. Don't really care. Fine, if it wants to be like that, be like that. Works on a Cessna. Works on other aircraft. I'll tell you why it doesn't want to work on this particular aircraft. I should have checked that one beforehand. It was working earlier. But there you go. You can see that we've reached 3,000 feet. And upon reaching 3,000 feet, it's leveled itself out. I didn't do that. I didn't do that at all. I didn't have to do that because it's gone, yep, okay, I've reached my desired altitude. Let me now keep it at desired altitude. And that's the advantage of this, particularly if you want to be flying at, say, if you're doing IFR flight and you want to be flying at 4,500 feet constantly through a busy jetway, and you want to be, you want to be flying around here and there, and you must keep it at that altitude. That's where something like this comes in very, very handy. It's very, very important. So that's the use. That's what we use for. Oh, we are definitely having a bit of a struggle here. So that's how we use the altitude. Now you can see here we're moving around. We're going to move on away from the altitude hold. You can see here we can turn our aircraft anywhere we want. And obviously the altitude, it does try and compensate. So you saw that as I turned, obviously with the wings turning, we've had this conversation about the wings turning, the lift, the change in lift force, so on and so forth. The computer had to compensate. So you saw I went like that, the nose went down, it lifted the nose up of its own accord to try and make sure we could stay at 3,000 feet, which is exactly where we are at this present moment in time. So now we are going to switch on to the next one that we need to have a look at, which is heading hold. So if I press, or first of all, before I do this, we've got this knob over here that we can rotate, as you can see, and it moves a green marker. Now on your aircraft it may be different, it might be a little white arrow or something like that, but on the heading or on the compass card you're going to see one of these knobs that allows us to move things around. So you can see there we've got that, it's moving things wherever we want. We're going to turn that now to a heading of 0. So you can see that. Now we're going to press heading hold. Watch what happens to the aircraft. First of all, it resets that green bar to wherever the current heading of the aircraft is. Okay, now we can turn this and it's going to turn the aircraft to follow. There you go. Look at that. It's turning the aircraft to follow, and also look at our vertical speed indicator. As we turn the aircraft, that started going down. The aircraft compensated, and you can see there with the upwards arrow, it compensated and said, hang on a minute, I've lost some lift, I need to lift the nose of the aircraft up. And it's gone ahead and done that to keep us at 3,000. There you go. Now it's gone to a downward arrow, if you have a look there, to bring it down. And we are now heading due north. How simple was that? That is how the heading bug works, and that's how we keep a heading as we pass through a cloud. This gives me a good chance to test if those... it's still not fixed. Still not fixed. I know that they're working on it. I can't wait until the next video, and when dynamic weather comes out, I'm going to be looking at all of this on the 1st of February. But for now, we're going to be flying through a cloud where we cannot see out. As I say that, we are exiting said cloud. Lovely. So now we're in heading mode, or heading hold mode, and altitude mode, or altitude hold mode. I was going to say not altitude mode. We're obviously at an altitude of some sort. We're not going to stay at any, whatever. Anyway, so you can see here we have HDG and ALT lit up on this particular screen. That is really low res. What this now means is that we have our hands off the controls, clapping, and you can see the aircraft is maintaining what it needs to do. It's not drifting left and right. However, we're going to see something very, very soon about the heading hold, and this is why we have tuned in the navigation for Trent, and this is very, very important when it comes to flying. Let's increase our power just a little bit. When it comes to flying, this is very, very important. We are going to get onto that radial, right? I know this point's 090, it's fine. We're going to be headed 270, it's not going to make a difference. It's just going to be in the opposite way to where the arrow is pointing. It's okay. What I want to show here though, and if we want, you can just look at this one. What I want to show is when we get on this radial, what happens when we use heading hold. And this is very, very important about when we're flying. It's a very important concept, so that's why I want to cover it. So we're just going to keep flying this way, and hopefully you guys are understanding how this works. A lot of clouds out here. You can see how wobbly it is, but look at those ailerons there. can you see the ailerons are working of their own accord? I am not doing that with my controls. They are working of their own accord. The computer is sorting it out for us. Right, we are coming up to the radial. So I'm going to I'm going to begin the turn, and I'm going to begin it again with the heading bug. I'm just going to wait just a little bit longer before we get this turned. And I'll turn the aircraft now. So we are now going to turn to a heading of 270, just like we've set up over here for the radial. Nav 2, radial 270. That's what we've set up. So, as a matter of fact, I'll even change this. Why not? Let's just have that 270. Doesn't really matter. There we go, 270. Okay? So now you can see we're pretty much on the radial. So you're probably wondering at this point in time, well, that's fine. Nothing's gone wrong. I'm now going to slow the aircraft down quite significantly to prove a point here. I want to prove a point, and it's going to be quite a point to prove. As we slow this aircraft down, not to that point, I'm just going to keep it slowing. We're going to slow it right the way down to maybe 120 knots, if not slower. I want you to watch, keep an eye on those two lines. And you're probably saying, you're not on the radial at the moment. You're right, I'm not on the radial at the moment. There's a reason why I've done that. Let's actually get that to 270 though. There's a reason why I'm not on the radial at the moment, and you're about to see why. Just keeping it below that noise. I don't like that noise. Just to slow the aircraft down. How slow do we want to get this aircraft? I think we can get it to 100 knots. Let's get it to 100 knots. Really slowing it down. Alright, you know what? Just idle it completely. Really getting this aircraft slowing. There we go, we're at 100 knots now. Maybe even slower. Let's get this aircraft a little bit slower. Alright, that looks good to me. 95 knots. You can see the nose is now pitched up a lot more, but don't worry about that. I just want you to keep an eye on these lines. You can already see they're getting a lot closer. Very interesting. How are they getting a lot closer if I am flying 270 and the nav course is 270? How does that work? How does that work? Well, simply put, because of the wind, we are being blown in that direction. And we've done the talk about crosswinds and speed, so we're going fairly slow and we're being blown over in that direction. If I go to an outside view at this point and zoom in, or zoom out, where is the aircraft? There's the aircraft. Right. Look at the way the aircraft is pointing and look at the way it's actually flying. Not the same. If I even go to... not that. Not that, not that, not that, not that, not that. I need to show a different thing over here. Right, well, speed's fine. I just need to double check the speed. Look at the flyby view. You can see which way the aircraft is flying as opposed to the way the actual aircraft is pointing. It's not the same. It's not pointing in the same direction that it's flying. And that is the important key here. Look at that. We are now on the radial somehow. Somehow we're on the radial despite the fact that we are supposed to be flying in the exact same direction as the radial. Therefore, we should have remained parallel to the radial. You see the problem? So that means that if we leave this in heading hold, eventually we're going to be off this radial. It's not going to be good for us. We're going to end up way off this radial. So that's no good, because that doesn't help us whatsoever. It's 270, right? I've set on it. Yeah, 270. I need to just double check that. So how do we compensate for that? How do we compensate for this issue that we are now getting? I want to slow this aircraft down even further just to prove more of a point. I want to really slow this aircraft down. Yes, yes. And you'll see the point I'm trying to prove as we slow below 80 knots. This is dangerously slow. This is flying dangerously slow. But don't worry, because we've covered stalls, haven't we? Right, we are very, very close to stalling this aircraft. But you can see now, there you go. You can see a bit of shake there. That's very close to stalling. We're okay though. We're going to keep it slow. We've got to keep it slow. You can see how we are moving away from that radial very quickly as the wind is blowing us in that direction. It's blowing us away, further and further away from that radial. So what we need to do is we need to change the mode on our autopilot to nav mode. Now watch what nav mode does. First of all, you immediately see the aircraft turns. What's it doing? Well, the first thing it's doing is it's lining up with our radial. So it's now using the navigation frequency of 115.7 and any associated components with it to line up with our selected radial, and it's doing it with an intercept angle. So now it is intercepting that radial. I am going to speed the aircraft up again a little bit. Alright, so now what it's going to do, it's going to get that radial back in the middle. We're going to intercept our radial, and then what it's going to do is it's going to fly that radial. So by making sure that we've set it up to fly 270 on the radials, I've done it on this as well just in case. As soon as it intercepts it, it will fly that radial. And that is how we use an autopilot to fly from VOR to VOR, or from station to station. Because heading hold is going to push us off, because to best explain this, what's a good way to explain this whilst the aircraft sorts itself out? Heading hold. This is how heading hold would work. You point in a direction. So let's say you're driving, or we're not going to say we're driving. Let's say you're just walking in a direction. You're walking in a direction and there is a wind blowing, or tell you what, you're walking in a direction on a treadmill sort of thing. It's not really a treadmill, it's one of those things where, you know, you can walk in every direction, but in reality you're staying in the same place. One of those sort of things, like conveyor belt sort of systems, where you can just walk or run or whatever. It's almost like a treadmill, but goes in every which direction. You're doing that, okay? Now that you've done that, you've suddenly got a force. So these treadmill things have started to move in a perpendicular direction to you, just like a crosswind does. But you've continued to walk in that exact same direction. What's going to happen here is that because you're being pushed aside, you could be walking forward, and whatever simulation or whatever you're in, you're still going forward. But let's say you're in a simulation where there's a box. Because you're being pushed to the side, you're going to end up hitting the wall. You're going to get to the lateral destination. So if you want to do it in, let's say, two axes, let's say this is the Z axis here, going forward and backwards. On the Z axis, you're going to get to where you need to be. Not a problem. However, on your X axis, which is your left and right, you're going to end up on one wall, because you haven't compensated for that. That is heading mode. You've not compensated for the direction something is pushing you, an external force is pushing you, and therefore you've gone off course to where your intended destination was. Nav mode compensates for this. So instead of you having to compensate as a human, going, okay, I need to adjust my heading, do some quick cross calculations for the crosswind, and say, all right, the crosswind is this at this, therefore I'm being pushed over at this kind of speed for this sort of setup, and therefore this is going to happen. I'm slowing the aircraft down again on purpose, because I want to show you something. and this is going to happen because I've got to this speed, and therefore I'm being pushed over in this direction this much, therefore I need to adjust my heading by so and so number of degrees to make sure that I am going on a relative heading, or the actual heading is this as opposed to the relative heading of the aircraft. So the aircraft is facing direction X, but direction X take away 10 degrees is where I need to be flying the aircraft, and that's going to help me out and get me to my destination. That's a lot of calculations that need to be done. The navigation mode does that all for you. The navigation goes, right, where am I? I am here, I've got onto this, I've done this, I'm going to maintain this, and whatever wind or whatever comes along, I'm going to compensate for that by turning my nose into the wind or out of the wind, and then from there I will then be able to maintain my trajectory to fly in the direction I want to fly. That's basically what the navigation mode does. So everything that you need to do, all the maths you need to do in your head, it does for you. And that's good, because if the wind is changing direction a lot, you can't do that maths very quickly. If the wind is going from 2 knots to 10 knots to 5 knots to 20 knots to 3 knots to 18 knots, so on and so forth, going to 30 knots, back down, a bit of a gust here and there, the navigation is going to compensate for all of that faster than you can, unless you're really, really good at maths. Now you look at that and go, right, sine of that is going to be this and this and this and this, and we need to change to 4 knots to take we need to change 4 degrees to 3 degrees to 10 degrees. I'm doing this speed. If I slow my aircraft down, if I speed my aircraft up, so on and so forth. That is controlling it all for you. And to prove my point here, look at this. We are pretty much bang on course. You can see that, bang on course, but, and this is the important one, look which way we are flying. We are not flying in the direction of the VOR. It's as a term of which way the aircraft is pointing. The aircraft is not pointing towards Trent VOR. As a matter of fact, it is pointing on a heading of 255 at this moment in time. 255 is where it is pointing to maintain a track, and I've spoke about tracks before, to maintain the track of 270. That's what it's doing. It's flying 255 to maintain 270 at 85 knots. As a matter of fact, it's actually wobbling further. But I'm going to bring up the speed again, and as I've mentioned before, when flying crosswinds, the faster you go, the less course correction you have to do. But there we go. That is how navigation works and how it differs from heading. Now, of course, we could say, let's hold this speed at 90. Let's say let's hold this speed at 90 knots. The navigation is going to sort itself out. We could bring this. You can see I've just brought the heading bug down to match that, and then switch to heading mode. Fine. That's not a problem. We can do that. And as a matter of fact, it's something we want to do at a certain point in time. I'm just looking for something here, which if I can't find it, it's not going to really matter. Oh no, there it is. So we've got the distance there to Trent. The distance is 15.3 nautical miles. Now, what's going to happen if we get to that point, 15.3 nautical miles away, and end up with this nav mode still on? Because as we get over the VOR, it's going to go crazy. This thing's going to start spinning around. We've had this before. We've seen how this works. It starts spinning around because every direction suddenly is the right direction, because we've just flown right over the VOR. It becomes incredibly sensitive. Any slight movement causes it to swing around, and suddenly it's going to go from zero, from this one, which is 270 on the 270 radial inbound, or the zero, I suppose in this case it's a 090 radial inbound. It's suddenly going to go to the 270 radial outbound. But we've told it to fly towards it on a certain frequency and a certain radial. Suddenly the aircraft's going to be like, what do I do? I don't know what to do. And the aircraft is going to get, the aircraft systems, the autopilot, is not going to know what to do. That's when we need to switch modes again. And luckily, it doesn't matter that we have to switch modes, because it's only going to be for maybe 30 seconds or so, if that. So all we do is we say, right, what's our heading? Look, we're speeding up, and you can actually see where, as we're speeding up, there's proof in the points right here. There's proving my point anyway. Not proof in the point. What's proof in the point? It's proof in the pudding, isn't it? I don't know what that means. as we've sped up to just over 100 knots, you can see that our course correction is not the same as what it was. So it was 255, now we're 260. So you can see there, we're now 260. So that's a new course that we can fly, or a new heading we can fly to maintain the radial at this particular speed. That's the important thing, at this particular speed, and the navigation system on the autopilot does it all for us. Now what we're going to do is, whilst we're doing this, we're going to use this altitude to lower ourselves a little bit further. How do I do that? If I do that and bring ourselves down, we're going to go to 250. There we go. And you can see that's actually now that's going to try a 1,000 foot per minute rate of descent. How smart. How smart. There we go. That's basically what we set up on the vertical speed earlier, wasn't it? Very clever. Very clever. But there we go. We're coming back down to 2,500 feet. In fact, I'm actually going to go to 2,000 feet. Let's try that vertical speed and bring that... There we go. -5. Now, interestingly enough, it keeps switching my nav mode off for some bizarre reason. I think that's a bug in the system where it shouldn't be doing that. If I go into any sort of altitude vertical speed mode, it switches my nav off, and if I go there, it's just being a little bit silly. It's honestly being silly, but we are maintaining a good rate of descent here at 550 feet per minute. As a matter of fact, we are slowing down, so the vertical speed indicator is now working, which is what I wanted to show you earlier. Like I said, a bit of a temperament, I suppose. But hopefully you guys are gaining a good understanding of how this works exactly. And as you can see, we are 8 miles away from that, but we are not too far from the airport. The airport is just over there. You can just see that the airport is... can we zoom in and have a look at the airport? There's the airport actually. Just over there. There it is. I was going to say, it's got to be somewhere there. There it is. Right there. There's the airport. Got some birds flying around? Yep, got some birds flying around. But anyway, that's how you use these different instruments. You can see we're now down to 2,000 feet and it sorted itself out. I didn't have to do anything. It sorted its own climb. It sorted its own climb speed. It sorted everything out for itself. I feel like trying a landing. I really do feel like trying a landing here. I do feel like doing that. But I feel like it's going to be an absolute disaster. I do feel like it's going to be an absolute disaster as I try and do this. Should I try it? I feel like trying it, but I don't want to try it. That's not the point of this video, and I want to show you guys the right thing, not the wrong stuff. So there we go. We've actually looked at the basic systems of an autopilot. As you can see, that vertical speed now works. But every time I press vertical speed, it just messes everything up. So let's ignore that. But it does work on other aircraft. I know I've tried it on Cessnas. It works on a Cessna. It works on plenty of aircraft. All the autopilot systems do work. Obviously, in a simulator, they may be a little bit bugged, depending on the simulator, depending on the vehicle of choice, or the aircraft of choice, should I say. But all in all, that is the importance of using an autopilot, for example, not just for altitude. That's just one thing. Mainly the nav mode and the heading modes. Those two modes are the important ones. So hopefully you guys have gained an understanding there. I'm going to end this video here. Thank you very much for watching. Please remember to hit the like button if you like this video. Subscribe to the channel for more videos on the ground up advanced flight tutorials. Let me know in the comments box below. I said that really funny. Tutorials. Let me know in the comments box below what you think. And if you guys did get an understanding of the autopilot, particularly the heading and navigation modes, which was the key part of this, not really altitude mode, because they work different on every single aircraft, but heading and nav modes work pretty much the same on every aircraft. So hopefully you guys did get an understanding of that. Let me know, and if you really enjoy these videos, don't forget to support me on Patreon. Link to that is in the description box below. I would massively appreciate your support. It would help me out a huge amount. Just to end this video off for a few more seconds, what I'm going to do is I'm just going to pick up a little bit of speed. We're less than 2 miles away. I want to show you what happens when we leave this in nav mode. Now, some aircraft have it that when the nav mode goes a little bit crazy, it'll switch back automatically to heading mode. I don't know whether this aircraft does. I really don't know whether this aircraft has that mode. I certainly hope it does, but watch what happens. We're only 2 miles away, and this is how we'll end. Now, just 2 miles away, you can see that it's going to go a little bit weird. Maybe a little bit more than a little bit weird, or it might kick back into heading mode of its own accord, but not all aircraft do that, so you do need to be careful of that. For example, the Piper Arrow 3 does not do that. Here we go, only a mile to go. Got a good speed going on. As you can see, we're still flying in that crosswind. The navigation mode is doing very well, but this is about to go all over the place. And this is the important part. Watch it go all over the place and watch. Let's see how the aircraft responds. Half a mile to go. 0.3 of a mile to go. It's starting to move. It's starting to move. It's gone crazy. Now look. There you go. It's lost it. It's lost the navigation there. It switched itself off of its own accord. We can go to heading hold mode. So on this aircraft, it just switched it off of its own accord. It goes, I can't find that. Sorry, I'm going to switch off navigation mode before I go crazy. So you've got to be aware of this. You've got to know how far away you are from a station, because if you're not paying attention, it's just going to switch itself off, or it's going to start trying to loop around. It's going to get very confused. It may switch it into heading mode, and suddenly you're lost. You're somewhere else. So that's where I'm going to end it. Thank you very much for watching, and I will see you guys next time in the ground up advanced flight tutorials.